Well, I've taken long enough or gotten sidetracked too many times, so I thought it might be a good idea this morning if we actually start changing out some of the capacitors in this radio. Now, in this particular case, I'm actually going to change all the capacitors. If you watched my video on vintage electrolytics, you know that I'm of the opinion that particularly the can electrolytics from a particular period, that the period from the mid-30s up until World War II, in other words, 35 through 40, generally I have found that you can leave them in because even if they later fail, they tend to fail open, so you can bypass them, and with a proper fuse, the set is completely protected, even if the electrolytic should short. But in this particular case, I'm just going to change out these electrolytics, partly because these are replacements already. You can tell that because this is in a bracket, but it has its own bracket which has been bent back so it can go in there. Also, you may notice that one of the leads has been taped, so we know that this is a replacement. So I'm going to replace that electrolytic, and but this morning what I want to do, or at least to start this video, is replace these two capacitors. This one, which goes from ground over to this pin, and the one underneath it. Now, I'm going to do both of those at the same time because, and this is where planning comes in, actually, when I put the new capacitor in, I'm going to put it under this one. The reason being that I can run the connection from this pin underneath and lay the new capacitor right flat on the chassis, which you will find if you do so, that puts the capacitor closer to the shield and cuts down on its ability to interject noise into the circuit. So the first thing I'm going to do, though, is I'm just going to use the soldering gun and some solder braid to take the solder off of this connection. And the reason is, and let me zoom in and maybe this will be a little more obvious. Well, pardon the poor camera work. But the way this capacitor was inserted at the factory is the lead was stuck through this pin and then run over to this pin. So it's wrapped around this pin, but it just sticks through this pin. So eventually what I'm going to do is just cut off the capacitor right here so that I leave the jumper between these 2 points, and then I insert the new capacitor in the pin, the tube pin here. But first, let's take some of that solder off. Now, you might be able to see, I don't know if this is going to stay in focus. It doesn't look like it's going to. Okay. You can now start to see what I'm talking about with the lead that just comes through here. Notice that there's no wraps on here, and that's mainly what I wanted to reveal. So what I'm going to do is actually just use a pair of diagonal cutters to cut this capacitor out, and then when I get ready to put the new capacitor in, I will just insert its lead through that spot there. At the same time, I'm also going to remove this capacitor. And by the way, this is rather interesting because the this capacitor has the outside foil connected to this pin of the tube, and then over to this, by the way, is the tuning capacitor. Let me show you what I'm talking about there. This lead right here, in other words, the other end of this capacitor is connected to the tuning capacitor. So I'm going to look at that on the schematic and see if it is proper to have the outside foil connected in this way or the reverse. I've cut out the two capacitors. They are both 0.05 mic, and I'll show you in a minute on the schematic. They are down here on the bench, and what I'm going to be doing now is I'm going to be comparing those with the ones I'll be putting in. And I'm going to start doing that using this Frugal multimeter that I talked about in the previous video. $14 on Amazon. No connection. I don't get any commission. Just like it. So we're going to test this capacitor. Having trouble getting it to make good contact. It shows 90 nanofarads. So that would be a 0.09 microfarad capacitor. The ones we're going to replace it with measure 45 or 46 nanofarads. These are 0.047s. The next thing, that's these yellow ones here. The next thing I'm going to do is I'm going to test the leakage of the new units using the DIY capacitor tester that you can find in another one of the videos. And I've got it connected there. I'm going to let it just hang like that, and I'll show you what it looks like on the on the capacitor tester. Now I'm using low voltage because that applies about 160 or 180 volts, which is all there is in this radio. I'm also doing that so I'm being fair to the other capacitors, because these are only rated at 400 volts, whereas these new ones are rated at 630. So you turn it on, you notice it flashes once and then goes out. I'll do it again. There. Now let's try the same thing on the old capacitor. Okay, and you see it comes on, goes off, or comes on and then dims, but it stays on, showing that this has leakage. Okay, well, you might say, well, how do I know this DIY capacitor tester isn't maybe being too hard on these capacitors? Well, what we're going to do is compare this now with a piece of very accurate measuring instruments, a Sencor LC102. Now, unfortunately, the backlight in the LC102 is not working. I probably could replace that. It doesn't cause me any trouble at the bench, but it does make it hard for the camera to see. So I have this set to 400 volts, which is the rating of those capacitors we took out. And then over on here you see the reading. You'll notice that the red light is blinking to indicate that there is a safety hazard. So the first thing we're going to do is hook up the new capacitor, and we'll check the capacitor value, and it says 0.0462. In other words, 46.2 nanofarads, or a 0.04. Remember, this is a 0.047, so that's very close to the right value. Then I'm going to check capacitor leakage. And it says 0.03 microamperes. Now, we're going to put the capacitor we took out on the leads, and I'm just going to hold them. And capacitor value, notice it says 0.079 or 0.08, and capacitor leakage 138 microamperes, so about 1,000 times more leakage. So that's the reason that we replaced those paper capacitors. And one of the things that I'm trying to illustrate is that a meter like this one and some kind of leakage tester, and this little DIY unit that is based on a design from Popular Electronics, as you see in that video if you want to go check on it, are basically all you need for radio work. So we're now going to put these new capacitors in, and oh, by the way, just a little kind of a my trick situation. You'll notice that I have some clip leads in there. I put those in there so that I will remember where the capacitors go. So for example, this clip lead, it goes from one end of the capacitor to the other end. So I'll remember where to put the 0.05s. And I'm using the same color because they are both 0.05 microfarad. Oh, I said I was going to show you those on the schematic, so let's take a look at that. Over here, this out of the way, one of those capacitors is this one right here, and the other one is this one right here. Notice that I have put check marks by them to show that I have replaced those. So let's go ahead and do that and then move on to the next step. And we have the new capacitors inserted. Notice how much more room we now have down in there. Next thing I'm going to do is replace the electrolytic, and then I will replace the rest of the paper capacitors. You see one here, another one over here, and then this is it's a plastic covered capacitor, but it's actually a paper capacitor, so I'll be replacing that as well. And yes, by the way, I have been marking the outside foils on these and using the same orientation as what is in the radio. Now, I haven't verified that that actually is the orientation that I would use, but I'll worry about that if I notice any noise pickup that is objectionable when the radio is up and running. So let's move on. I'll try to finish the capacitors and come back after that. I've been tracing out the ground lead of this electrolytic to see where it goes, and eventually I traced it around to this wire. Now you may wonder, there's no insulation on that wire. What is happening is that the insulation is flaking off. You notice all this little parts here, and this is still reasonably flexible here, but where the wire ran inside, all of the insulation just flaked off of it. So what I did is I eventually traced it back to this point, which is tied to one end of the switch, the power switch. Let me show you in the schematic what that is all about. One end of the power switch is tied to the B minus, we call it ground. And you notice over here that the 30 microfarad section is also tied to ground, and then over to the 35Z5. The 30 microfarad section is the red. You see it says red I'm sorry, blue, and then the 50 microfarad section is the red. So where is that? Well, I've showed you the 30. It's down here, and the 50 is right up here. Notice it says C19A, and this one is C19B. So this is the 50, and that's the 30. So now what I'm going to be doing is replacing the electrolytic capacitor with a pair of modern electrolytics, a 50 and a 30. I've now replaced the electrolytic, dual section, with these two electrolytics. Let me zoom in a little and show you what is going on there. This one is connected across this way, and I'm taking advantage of closer ground locations like this one. Similarly, on this one up here, I took advantage of a closer ground location. You see, there's one connection over here and one down there. So now I'm going to finish replacing the paper capacitors, this one and this black plastic one here and this one over here. But before I leave with the capacitor replacement, and oh, by the way, there are a few things that I would like to do in some future videos, but not in this one. One is try some other options for doing the outside foil detection, including maybe using a signal tracer instead, and in some units you can even use the unit itself to help you with that. But we'll talk about that in the future. But before I left, I thought I might talk to you a little bit about why it's so important to replace capacitors in tube sets. Probably as good a place to illustrate it is right here. Here you see there are two capacitors, one going to ground and one going from this point to the next grid. Well, this is the plate, which has says it should have about 52 volts right here. Well, if this capacitor is leaky, it will pull that voltage down or pull current out of that node to ground. That not only will put additional strain on the power supply, but it also will cause the total unit to draw more power, even to the point that if it draws too much power, this capacitor can even overheat and explode. It's unlikely that this capacitor will catch fire before the filament of the 35Z5 blows. You may remember I talked to you about the fact that the current that flows through the plate of the 35Z5, which supplies all of the B+, comes through this bottom section of the filament. Well, that's kind of a fuse. Now, I don't like using the tube filament as a fuse, but what will happen is if you draw too much current out of this point, is the 35Z5 filament will overheat and burn out, and so will the dial lamp. So let's go back to our circuit and talk about that other capacitor, the one going from plate to grid. If this capacitor is leaky, what will happen is some of this positive voltage will wind up on the grid of this tube, causing this tube to conduct more heavily. That also will put additional strain on the power supply and will also cause this tube to operate outside its normal operating limits. So you not only might lose the 50L6, but you also might lose the 35Z5 at the same time because, once again, it's drawing too much current. So that's the reason why you replace the capacitors. Obviously, the reason that you test the capacitors before you replace them, before you use them, put them in the circuit, the new capacitors, is to make sure that they are of approximately the right value, and that you can use a multimeter that has a capacitance range for that, and that they don't leak too much. And that's why I use that little DIY leakage tester. Now, the one thing I will say is that DIY leakage tester is not as good on electrolytic capacitors. It will work, but some electrolytics that will still work in the circuit will sometimes show up bad on that DIY tester. Only really good electrolytics will show good on that DIY tester. But at any rate, that's not what it was intended for anyway. It was intended for testing wax paper and film capacitors like this little 0.05 mic there. So enough about capacitors. Let's wrap up this video, and next time we will be replacing the power cord, which you see kind of hanging in the breeze here. Also, you may notice some clip leads on some wires here. Those are wires where the insulation has flaked off, and I'm going to replace those as well. But I'll do that in between videos. So when next you see this, we'll be ready to start replacing this line cord and adding a fuse, and maybe even starting to power this receiver up. Hope you enjoyed this one. Look forward to the next one. Have a nice day.